All right, well, let me give you an overview of the hardware, then we'll get into the software. The X-ray unit is about 7 years old, the technology for the pin diode detection system. This unit is a couple years old, but the hardware just going to raise the table up so you can see. Alright, so from a plater standpoint, this kind of instrument is beautiful for them because if you notice, there's nothing really binding or that can get into the base of the unit. So a lot of jewelers who have the older type of X-rays will have exposed gearing and stuff. So if you drop a chain or something like that, it just gets loaded in and it gets lost and it can get broken. This kind of unit, it's solid. We have very, very strong parts in here. We can put parts up to 8 inches high. We have the table, which is the blue area of measurement here. It has the platform in which it sits on produces the least amount of noise. And whether we know it or not, X-rays, when they go through, the primary beam goes right through everything. And it's being absorbed in the actual support of the X-ray. So when someone says, well, how thick can you measure something? Depends on what you're shooting. But the primary beam that's being produced by a tungsten target tube is going through everything. So we need something in the support that's able to absorb that. When you're shooting any kind of small parts, when it comes to, you know, the clasp or something like that, any X-ray that's going to be deflected or moved, if it's going to hit the actual substrate or the support, it's got to be absorbed and give us the least amount of noise, so that everything that we're measuring does not give us false positive based on the support. So, as you can see, we can move the stage around and move it in any kind of particular area, allowing us to position parts in which we need to measure. So, do we have a part that we're just grab any one of these?
Yeah, I think those are some.
So the instrument has a programmable X, Y, and Z. So if you can put multiple parts in there, you can put 50, 60, 200, 300, 400 parts in there, program them all, let the machine run and walk away from it.
And it's important to also emphasize that the samples that we're using are not affiliated with any particular vendor or retailer.
So we put it on there in the spot, allows us to get to the area of measurement. We have a point and shoot system so that wherever the mouse is, we can actually point on that part and measure. Our focal point allows us to get to a certain area of measurement, and we can do a focus laser so that we can at least get close enough to be within focus. I am now 46 years old, and I've had to now wear these. My wife wants to pick on me about it, but everybody has a different focal point. Okay? It's very important that when you're measuring, especially with pin diode detection, that we operate using a laser. Because then we don't have to worry about the focal point anymore. Because what you'll notice inside the industry is that you can get your parts in, and I think we talked about this in worrying about are we getting 3 mils of gold. You can make an X-ray read what you want it to be. My source of sales today is incoming inspection, because everybody's now determining they're not getting what they ordered. So I'm getting a ton of sales in that. This allows us to measure at the same point of focal for everyone in the room. Okay? So that's important. So a lot of companies I go into, we developed an application for operators that allow them to do some kind of screening process. And that would be, we call it, what is it? Because we do not want an operator making any kind of corporate level decisions on the kind of data that they get. So we put something like this in it called what is it? It gives them some kind of screening that just puts it in this pile or it puts it in this pile. Or we put it into this kind of company that says, we want to know what it is. So in this case, we don't know what it is, so we're just going to shoot it. We set up the instrument so that point right there is being measured. That circle you see right there is the actual targeted area. That's the size of the beam when it reaches the part. So that measurement will be taken right there on that spot. The X-ray, the crosshairs, and the video are all lined up. So what this will do is this will start giving us a real-time measurement. Once it starts processing the electrons. So now it'll start giving us what we might see in here. So we see the silver, we see the gold, and then we get our measurement. Now this is set up for 30 seconds. We can, and this is just for a quick screening, for a lot of other customers out there, and including here, we can move that up to 5 minutes. But this is just for a quick screen. So in our measurement, you can see we're getting a lot of zeros, 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 and then you get down here, 79% silver, 12% gold. Now here's where an analytical facility needs to make some kind of visual. So we have a spectrum up here that we know that we can highlight, you can see in CSI. And then, well, what is this little peak? If we click on the silver, because it told us there was silver in there, you'll now see where the pins of silver lie. So it gives us a good indicator that that's silver. Now if we go back out and we look over here, you say, well, it sees gold. So if I just move this back and forth, I'll just put it on this right here. You say, well, what is this? Well, the alpha line of gold is showing up. So if I right click and I choose gold, there are all the peaks of gold. If you'll notice, we have down here tungsten, 6.5%. So wow, how much tungsten is supposed to be in here? Well, if we click the tungsten, you'll notice the tallest peak of tungsten should be shot right there. From an analytical lab standpoint, you would know that that is just not there. It's not physically there because we can't see it. So in our measurement, we would probably broaden this out to 3 minutes, take a longer measurement time so that we can actually get rid of the false positive. So it's all part of just looking into the software, visually inspecting what the spectrum is showing us, not just the final answer at the bottom. We set this up in percent, so it gives us an indicator of what might be on the part. That gives us a determination of what we would be shooting for an application of measurement.
So Ken, is this initial scan that we're doing more for a material identification?
That's what this is set up for, so that now he can determine what he's going to use for an application to measure for thickness. What's he going to shoot? So in this case, we know it's probably, we take some information to our measurement with us. This is supposed to be gold on silver, or gold on sterling silver. Okay, well, we look at it, we can visually inspect it, there is gold there. Put it in there, and we see all these lovely peaks that are showing up inside the spectrum. And it allows us to say, well, there's the silver, there's the gold. So we can verify, is it gold on silver, or is it gold on brass? Is it gold on nickel on brass? Is it gold on palladium on brass? You know, whatever it's going to show up as. So, yeah, just kind of a screening and seeing what we get.
And is it too premature at this point in the evaluation to determine if there are any restricted types of substances present? For example, lead or cadmium.
Well, you can certainly, there's some certainly screening that you can do, because we can look at the cad and see that it's 0.
Mm-hmm.
And we can bring it down to the lead and see that that is 0. All right? So, yeah, well, it's well within the realm of getting a quick answer if it's...
So despite the fact that we've had a lot of dialogue that's been going back and forth, look at the time frame that we were just able to determine lead content compared to what we've historically, had to endure.
And if you look at it, you look at the nickel, and we're all talking about that's at 0.
Right, but that goes back to the question of if there was nickel detected, is this capable of coming up with a migratable?
No. Well, I think that's what you're going to have to determine. Is there a process in which the coatings are plated on? Those coatings have to meet a certain criteria for thickness, so that you can make a determination for the migration through that thickness. We all get it in one measurement. you can make that determination. If this happens within a thickness measurement, then we can actually state that the migration is not going to happen under a certain percent, right? So
Well, I think the question to that would then be, if you've got a copper-based piece, of which you then plate several different films, including heavy copper, how do you distinguish between the plating copper and the substrate copper to know whether or not, if your nickel is beneath that, let's say, how do you...
underneath the copper?
Under the plated copper, not the substrate copper. Can you distinguish the layers themselves?
Well, I don't think, is there anything in the jewelry that's made from copper? Isn't it all brass?
Or brass, let's
Well,
say.
the machine, if you're setting up the machine in advance to knowing what the brass is, it can absolutely make a distinction between the two for thickness. For where that copper is in our big bowl of water, when you take a cup and you don't, no one knows, it's just swimming in there. So the electrons that are coming off of copper all get put into one lump.
One bolt.
The only thing it's going to do is be able to discern that if there's copper present and there's zinc present, and you've said what that looks like, or you told the machine what it looks like for percentage, if it's 60-40, 70-30, 90-10, it's going to be able to determine what it is.
So traditionally, you know, we could do a spot test with a solution that would tell us if, you know, the outer layer had nickel present. And if it did, then we'd proceed with the wet chemistry leaching test, which took 10 calendar days. So with this type of equipment, now we're able to look at all layers, substituting this for a spot test. So we'd be able to make a determination. And if there was a, you know, an indicator that there was nickel there, very similar to what an XRF would have, the process with an XRF for detecting lead, you would have to, you know, proceed on to next steps. So it's not going to eliminate at this point having to do a nickel leaching test until the science has evolved that says if there are only, you know, 0.001 content, you know, then, you know, that's exempt. But that's going to be something the CPSC would eventually have to weigh in
So
on.
if this was gold over silver, why isn't it registering 92.5% silver? If it was sterling, it was...
Well, we haven't set up the instrument for any kind of analytical answer for the sterling.
Oh,
We just set it up to give us a gold thickness.
I see.
We'll do it. So, in this case, I'll just let it take the full measurement.
So I think that the quick answer to that is it's all how it's initially set up to run. Is that correct, Ken?
Right.
So if we're
Well,
doing...
I mean, it's absolutely GIGO. Garbage in, garbage out. We're not calibrating this with, you know, certified standards, with something that's given us a value that we can count on.
Mhm.
We're going to get jumped out. There are some setups in the instrument that give us, you know, a set of fundamental parameters that can get us within 10% of answers, but you should always use certified standards for the value. So if we went to his gold and silver application, you can take a measurement on that and determine what is the thickness of the gold.
And
28 microinches or mils, or however the jewelry people want to use it.
the unit of measurement is micro...
Microinches. Or I learned 20 years ago when I walked into a company and they said, we put 3 mils on there. 3 mils? 3,000 microinches? That's 3 millions.
Mm.
That's 3 mils. 3 microinches. And so in this case it's 28.6. Over, focus. Now, one of the things that we get a lot of calls for, even in my facility, is the getting into any kind of correlation issues with those who do plating, measuring users, because even both of them with XRF will get 2 different answers sometimes. Will be used in the middle to kind of determine who's right. a lot of that is determined on what is the actual coating and what's underneath that coating, and making sure that the calibration is set up properly to measure it. So you may find that more prevalent out there today. Now, if I go out of focus a little bit, and we just measured that at 29. Now it's down to 26. So now, the spec was 30, end user would reject it. But if I was the plater and I decided to get a little closer, I could accept 30 now. That happens all the time.
So the readout or the device will not indicate that it was out of focus.
And all platers know that. This happens everywhere. The CFC that comes through the door doesn't mean it is what it says it is. Because I just went from being out of spec to being in spec. You've probably seen that.
I have, and tried to explain or simplify it to the Chinese who do this in-house with the regular handheld. It's like, one's got it up here, and saying, yeah, your beam's all over the place, you're picking up everything, and stuff like that. And then they get too close, and they're almost hitting the piece, and I said, you're still out of it, you gotta make sure you can see it. So it goes from 10 mils to -3.
So we get this kind of data, we can certainly export it, we can Excel it, we can attach the picture in which the area of measurement was taken. So if you're looking on a chain and there's something that's been marked or something, we can shoot that. And that can be totally exported in the Excel program. Of course, if it's networked, it can give you those kind of answers instantly. You don't have to worry about the stuff being shipped back to you. Here's where we measured, here's what we got for an answer, and here's the full report. So that is something that has been developing over the years. So they have actually migrated Excel right into their program.
Ken, I got 2 questions. One, when this is set up and you set up your standard, all right, when the beam goes down, at what point does it know when to stop before it hits a substrate?
Well, the beam doesn't stop. The beam continues.
Right, but your data
So we're going
points-
to look at it's going to look at what is an infinitely thick substrate.
Okay.
So it knows that once it's seen nothing else, then we know that the amount of energy that we're seeing from the substrate is giving us sufficient amount of count rates or X-rays to say that that is infinitely thick.
Could that substrate material be added into the plating thickness or any of the layers of thickness?
Only if it's thin and you have to and it's picking up whatever's going on the other
Oh,
side.
okay.
So for instance, we have a lot of people who do a lot of gold copper on plastic. There's a lot of plastic material out there. Or even silver, a lot of silver buttons and stuff like that. We'll actually set up the X-ray to measure both thicknesses on both sides, have the machine divide the thing in two, and you get your actual thickness all over on the part. It's used a lot inside the medical industry because a lot of their parts are made plastic and the coating is all over the part. So we're able to measure that.
My second question
In
is...
this particular case, if you have gold plate on both sides, why isn't that then split in half?
The substrate is probably thick enough to just keep the beam to one side.
Okay.
So it's not, even though the beam is going through everything,
Right.
that silver is thick enough to say, nah, that's infinitely thick. So even though it might be hitting the gold on the other side, that's not going to come through that silver. There's just no way, it's too thick.
Okay.
So my second question is, my protocol says 5 random readings over that. That comes up on the screen, you actually get a printout of all 5 readings and then the average, correct? That's okay.
Yeah, and you can certainly, in something like this, I can show you that, you know, if you're requiring to get an answer for 5 readings, we can program the unit I'll just do 3. But now, it'll measure in each one of those points that I just programmed.
And will you get an average?
You get an average. You can also set up the instrument too, to take 5 readings in one spot and get the average of those 5 readings for that one spot. And you won't get the 5 readings, you'll just get the one answer.
Ah,
So
okay.
this will allow you to do, so we have some who want, who will go 5 readings 5 times, so a total of 25 readings, but only getting the 5 answers. Some of them do that. It's, a lot of military facilities use that today, especially for filters and stuff like that, when they want to make sure everything is absolute. They don't want things falling out of the sky.